This week we are covering Chapter 4, Dimensional Analysis. Dimensional analysis is a method that we are going to use for the remainder of the semester to calculate our dosage problems. So this week we're going to start with more word problems that are more common to us on a day-to-day basis instead of medicines. So hopefully it'll make a little more sense to you by using common scenarios. And then as we become more comfortable, we will transition over into solving our dosage calculation problems using dimensional analysis. So for the Chapter 4 homework, you'll see that I've posted several videos. The first one is a YouTube video shown here, and then if you scroll down further to the instructions, you will see another YouTube video for dimensional analysis, as well as an old lecture video from one of my classes that I've previously taught. I've had a lot of technical difficulty for the last few days, so hopefully I've got that worked out and am able to finish recording this video with some additional problems for you to work through. So some key things about dimensional analysis. If you look in your textbook on page 56 at the very top, there's a yellow box that says Summary of Dimensional Analysis Steps. So these steps are what you need to be thinking through each time you work through a problem. Number one, we're establishing the answer's unit of measure. And this means essentially, what are we solving for? What is our answer going to be in regards to units? So are we solving for beats per minute? Are we solving for teaspoons? Are we solving for miles per hour? Whatever the case may be. So what are we looking for? Number two, insert the given quantities. So what we're going to do with dimensional analysis is we're basically going to make a series of ratios, and those ratios are going to be set up in a situation to where their units of measure will all be canceled out with the exception of what we're trying to solve for. Now, these ratios are not fractions, therefore these ratios are showing relationships between two things. And a lot of times we're going to find these relationships given within our word problem. If they're not given within our word problem, we're going to go to step number 3 and see if we need a conversion factor. Okay, so those conversion factors, if you go to your homework, you will be able to find those conversion factors in a worksheet, and it's not linked to your homework. My apologies. Your week 4 or week 3 for chapter 4 known variable conversion cheat sheet, essentially. So this is the one that you're going to need to download and use for all of your conversion factors. You're not going to go to Google and Google how many feet are in a mile or how many milliliters are in an ounce, because I'm only going to utilize these variables that are on this sheet to determine the correct answer for the problem. So make sure you use those conversions. Okay? So going back to the textbook, we've talked about some of these steps. So once we see if a conversion factor is needed and enter that, we're going to calculate the answer. Make sure we cancel out the units of measure as we go through, and then calculate the answer, critically evaluate the answer. So essentially, does the answer make sense? Is it feasible? Is it plausible for that answer to be correct? So let's work through a few sample problems. If you go to page 63, we will work a couple of these practice problems. Number 1, a cake recipe calls for 3 tablespoons of baking powder. 3 teaspoons is equivalent to 1 tablespoon. How many teaspoons of baking powder is in the cake? So the first step we need to do We go back to page 56. Number 1, establish the answer's unit of measure. Okay, so in this we are looking for teaspoons. Okay, so for my problem, teaspoons equal. So that's the very first thing I do every time I set up a problem. What are we solving for? And I write it down. So whatever is next to the equal sign on the left side of the equal sign on the equation, that's going to be the unit of measure in the numerator, or the top, on the right-hand side of the equal sign. Every single time. So if you do not set your problem up beginning with the unit of measure the same on both sides, then there's a high probability you're going to get your answer wrong, or you're going to set up your problem wrong. So, starting with teaspoons, what in my problem does it tell us, or what information does it give us related to teaspoons? Well, it tells us that 3 teaspoons is equivalent to 1 tablespoon. So that's a relationship between two things. 3 teaspoons is equal to 1 tablespoon. Okay? So then I'm going to have another ratio. And the label of that top information is going to be tablespoons, because I want tablespoons to cancel out and not be in my final answer. Okay? So what does it tell us about tablespoons in my problem? It says that 3 tablespoons are called for in the recipe. So if you noticed in your book, it said we can simplify some of these units of measure. And in this case, it's just telling us we have 3 tablespoons in this recipe. There's really no other information related to that. So we can put that 3 tablespoons over 1. If you recall back to the fraction chapter, if you put any number over 1, it's equivalent to itself. So it's not changing the value of that number at all. So 3 tablespoons over 1 means 3 tablespoons. So I've canceled tablespoons out. I have teaspoons left. And since that's what I'm trying to solve for, then I'm going to assume that my problem's set up correctly. Okay? So then I just do the math. 3 times 3 is 9 over 1 times 1, which is 1. So my answer is 9 teaspoons. I want to critically evaluate that answer. Does that make sense? Is it feasible? Is it possible to have 9 teaspoons in this recipe? Well, if there's 3 teaspoons in a tablespoon and I have 3 tablespoons, then yes. I can do that math in my head and kind of assume that that's correct. In some of these problems, you might feel like it's easier for you to work them in your head, but if you will write these in dimensional analysis form, then that will give you more practice and make you feel more comfortable with setting up the dimensional analysis once we move on to dosage calculations. For another example, let's look at number 7 on page 63. So number 7 might kind of trip you up based on what I've told you to do so far. So number 7, how many minutes are there in 14 weeks? How many minutes are in 14 weeks? So what are we solving for? Minutes. So minutes is what I'm solving for. Minutes equals. So what do I want on the right-hand side of the equal sign? Since minutes is on the left, I want minutes on the right. So if I look at my known variables, that conversion sheet that I provided for you, this one doesn't have anything related to minutes. However, I know that 60 minutes is 1 hour. Okay, So that's the conversion that I'm going to use. So 60 minutes over 1 hour. What do I want as my final answer? Minutes. So I want to cancel hours out. Do we have a conversion related to hours in relationship to the week? So I know that I want to end up with weeks somewhere in my problem, but I do know that there are 24 hours in one day, right? So that's going to cancel that out. I also know that there are 7 days in 1 week, right? So that has canceled out days. I've got minutes on top, week on bottom, and I know that we're trying to figure out how many minutes are in 14 weeks. So that's given to us in the problem. And what is in relation to those 14 weeks? There's nothing that's related. So if I put it over 1, then that's going to kind of hold my place and not change the value of anything. So week is canceled out. I have minutes left. Okay. So I'm going to calculate the math. 60 times 24 times 7 times 14 all over 1. So if I calculate that, I should end up with 141,120 minutes. Let's switch over to your homework and do number 25 on your homework. It actually is related to medication. And this might be a situation that you've been in before if you have a child. A parent consults a pediatrician about the amount of ibuprofen to give her son for a fever. The pediatrician advises the parent to administer 3 droppers full of ibuprofen elixir to the infant. The bottle of ibuprofen elixir comes with a dropper that holds 25 milligrams of ibuprofen. How many milligrams of ibuprofen is the child getting if the parent administers the dosage recommended by the physician? So we are solving for what? How many milligrams? And I'm going to abbreviate that mg. So I'm solving for milligrams, and I want milligrams to be on the top in my first ratio. So looking at my problem, what do we know about milligrams? Well, it tells us a dropper has 25 milligrams of ibuprofen in it. So 25 milligrams is to 1 dropper. I don't want dropper in my final answer, so let's get rid of that. What else does it tell us about dropper? The physician or pediatrician advises the parent to administer 3 droppers of ibuprofen. Now, what is that related to? Well, you could do a couple of different things. You could put it over 1 to hold the place because we're not changing the value of that. Or some might say 1 dose because we're looking for milligrams per dose and they recommend 3 droppers per dose. But I'm just going to put it over 1 for now. That cancels out the dropper and I'm left with milligrams on top. So I'm going to assume that my problem's set up correctly. And I do the math. 25 times 3 is 75 over 1. So 75 milligrams is how much the physician is recommending to administer to that child. So I'm hoping by you seeing me work through a few of the problems that might help you get started in setting up your own problems and getting your homework completed. What I do encourage you to do is if you have any questions or you would like to meet with me one on one to work out some problems, I'd be more than happy to do that with you. Simply just shoot me an email through course mail in my Ozarka. You can call my office at 368-2081. I can travel to different campuses and meet with you one on one also as both of our schedules allow. So I will be at Ash Flat tomorrow, so February 1st. I will be at Ash Flat most of the day. So if you're local to that area and want to stop by and work through some of the problems, I'd be happy to do that as well. But like I said, if you have any questions or need any help, please don't hesitate to reach out. If you don't feel comfortable with this material moving forward, then you're going to continue to have difficulty. So please reach out and let me know if I can do anything to help. Have a great day.